Um, we're all familiar with equalities. This here is an equality, x is equal to 3, and it's called an equation. And there's only one solution to it, x is equal to 3. I could make it slightly more complex, as complex as I like. I can x plus 1 is equal to 3. There's still only one solution, it's an equality, and x in this case is equal to 2. But over here on the right-hand side, we have an inequality. X is greater than 3. Well, that means that x can be equal to 4, 5, 6, 7, 8, 9, 10, up to infinity. But it also depends whether x is an element of the natural numbers. In that case, x is going to be equal to 4, 5, 6, 7, 8 up to infinity. Or else we're told that x maybe is an element of the real numbers. In which case, now our solution isn't just natural numbers. Now our solution is everything that's greater than 3, but it could be 3.000001 up to infinity as well. And the way they're actually plotted out, if I have 3 here, 4, 5, 6, an arrow here. If x is a natural number, I'm just going to have a circle around here, 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 and so on. But if x is a real number, okay, like here, then I'm going to have this circle around here, and I'm going to have a solid line going this way, indicating that everything on this line is going to be included. Okay, so that's a little introduction to inequalities. Let's have a look at some junior cert questions. So, complete the inequality in n below so that it has the solution set shown. Well, here's a solution set. There are 3 numbers in it, 2, 3, and 4. Notice it doesn't include 2.5 and 3.5 and so on. Just these 3 numbers. And I see that n is a natural number. So n has to be greater than or equal to 2, okay, and has to be less than or equal to 4. And n is a natural number. So that's it. That's done. This one is just a little poser. Complete the inequality in x below so that there's only one possible value for x, where x is a real number. So what number can go here and here so there's only one possible value? I mean, if I put in 1 here and 2 here, there's an infinity of solutions that can go in there, so that won't work. I could make this 1.01. There's still an infinity of solutions between there and there, so that's no good either. So the solution to this would be that this is 1. So they're both 1. Or they could be both 2. Or they could be both anything, but they're the same value. Okay? So you can just pick any value here. But it has to be the same value. And then there's only one solution. Okay. Sometimes inequalities are combined and there are 2 inequalities. So there's an inequality on the left hand here. Minus 17 is less than or equal to 1 minus 3x. And then there's one on the right hand side where 1 minus 3x is less than 13. So what we can do is we can solve this all in one go. What I'm going to do is I'm going to get rid of this 1 first. I'm going to get the same as I do with an ordinary equation. I try to get the x on its own. So I'm going to subtract 1 from both sides. This one here I'm going to subtract from both sides. So I'm going to get minus 18 is less than or equal to minus 3x. And that's less than, 13 minus 1 is 12. Okay, let's divide across by 3 now because I'm still trying to get the x on its own. So minus 18 divided by 3 is equal to 6. So it's minus 6 is less than minus x, which is less than 4. You notice I didn't divide across by the minus 3. I just divided across by the 3. Now there's something I will show you in a moment when you're multiplying or dividing an inequality by a negative sign. It changes the direction of the inequality, and I'll show you that in a moment. But for now, to solve this, let's just multiply across all sides, all this, and this, by minus 1. And when we multiply by minus 1, we'll change the direction of these inequalities too. So let's do that in green. So 6 is greater than or equal to x is greater than minus 4. Now in inequalities, you always want the negative number, the smallest number on the left, and then the biggest number on the right. So I'm just going to swap this whole thing around. So I'm going to make it minus 4 here. Minus 4 is less than x, which is less than or equal to 6. So let's have a look at that. You see the x is greater than the minus 4, x is greater than the minus 4. And then the x is less than or equal to 6, the x is less than or equal to 6. So you get this nice natural way that you've got a minus 4 is the smallest number, x is bigger than that, but x is greater than the 6 as well, or less than the 6. So it's natural. You've got the smallest number, the middle number, and the big number. If we left it like this way, it'd be the wrong way around. You'd have the biggest number on the left. So, okay. So now we just have to plot that. We notice that x is an integer, So x is going to be greater than 4, greater than minus 4. So we're not going to include minus 4. We're going to include minus 3. We're going to include minus 2. We're going to include minus 1, 0, 1, 2, 3, 4, 5, and 6. So there's going to be dot on each one of these because it's an integer. Sorry, it's an integer, and you notice it's greater than minus 4. So we're not including minus 4. All right. Don't forget, you have actually just solved this inequality here. You found the value for x such that 1 minus 3x, and if x is in this scale here, so you could check it, for example, 0. 0 is in this range, isn't it? So if I put a 0 in here for x, I'm going to get minus 17 is less than 1, which is correct, and 1 is less than 13, which is correct. If I went outside this range, just say I picked 10, well then this would not be true. Okay, you'd have minus 17 is not less than 1 minus 30, for example, so that'd be minus 29. So that's not true. So it's only for these values that it's true. Okay, let's move on to the next one. Okay, here's an example of an inequalities question. Neve is in a clothes shop and she has a voucher which she must use. The voucher is worth 10 euros, but she only gets that when she spends 35 quid, more than 35 quid. And she also has 50 euros in cash. Write down an inequality in X to show the range of money she could spend in the shop. So she must use this voucher. The voucher is 10 euros and she only gets that to use it when she spends 35 euros on an article, more than 35. So if the article is 35 euros and a penny, okay, a cent, well then she can use her 10 euro voucher off, which means she has to spend 25 euros in cash. So she has to use 25 and it has to be greater than 25 euros, which is fine. So 25 euros. And then it has to be less than, well, she only has 50 quid in cash, so it's going to be less than 50. So the inequality is for her cash, she has to spend a minimum of 25 and a max of 50. Okay. Write down an inequality in Y to show the price range of articles she could buy. Okay, so, well, the cheapest thing she can buy is going to be 35 euros. So that's the cheapest article she can buy is 35, isn't that right? Because then she can use her 10 euro voucher. And the maximum thing that she can buy is going to be, which is 50 quid cash. So she could spend up to 60 euros. So 60 euros would be the 50 euros that's on the label plus her 10 euros that she can get off it. So the maximum price of the article would be 60 euros. Here's the written solution for that in the in study click, so you can read that and see if it adds more value if you need to. So you can pause that and let's go on to the next question. I said I would explain to you how multiplication by a negative number works. So let's do that now. Okay, so if we consider an inequality 6 is greater than 4, fine. If we multiply both sides by minus 2, we're going to get minus 12. And then if we left the inequality pointing the same way, we're going to get it's greater than minus 8. But that's not true. Minus 12 is not greater than minus 8. Minus 12 is less than minus 8. So this illustrates the inequality sign must be changed or reversed when both sides of an inequality are multiplied or divided by the same negative number. Well, here's two little simple examples. You can read them yourself and see that it makes sense. Okay, here's an example of reversing the inequality sign. So to solve this, so we write it down. We get x on its own, so we're going to subtract 4 from both sides. So we're going to get minus 3x is greater than minus 5 minus 4, which is minus 9. Then multiply across by minus 1. That means it's going to give us 3x. We reverse the sign to make it less than 9. X is less than 3. X is an integer, so you're going to get x is less than 3 and it's an integer. So 2, 1, 0, minus 1, minus 2, and so on to negative infinity. Okay, I hope that helped, guys. Thank you.